only thing we can be sure of about the future is that it will be absolutely fantastic.
5, 4, 3, 2, 1.
On November 12, 2017, the world's first space nation launched its inaugural satellite into orbit. You can't see it, but my hands are doing a lot of air quotes here. The nation, called Asgardia, was founded by Russian engineer Igor Asherbely. The ultimate goal? A giant pluralistic country in orbit around the Earth. A peaceful, demilitarized, pluralistic utopia, which has among its stated aims a major role in planetary defense against asteroids. It's a utopian fantasy, of course, a proto-Valerian and the city of 1,000 planets, but the satellite is real, a small box about the size of those ghost traps from Ghostbusters, loaded among the other payloads on a rocket and left to drift above the Earth. On it is a hard drive carrying Asgardia's constitution, national anthem, flag, and information on the over 115,000 people who've signed up as its first citizens. The form this little nugget of aspiration takes is a CubeSat, the miniature, standard-sized satellites about as big as a loaf of bread that are making wild experimentation and the democratization of space possible. They're allowing private organizations, university researchers, and students to engineer projects for low Earth orbit, like the students for the exploration and development of deep space here at UC San Diego, who are building a CubeSat called Tritea, competing to be one of the first CubeSats to explore deep space. On this episode of Into the Impossible, a podcast of how we imagine and how what we imagine shapes what we do from the Arthur C. Clarke Center for Human Imagination at UC San Diego, we're exploring speculative CubeSats. Two in particular, the Lightsail project to test solar sail technology and created by the Planetary Society, and the MacArthur Genius grant-winning artist Trevor Paglen's Orbital Reflector project, the first satellite to be launched into space purely as an artistic gesture. Through these, we will explore how lower costs and commercial rockets are making such experimentation possible, and how they shape the way we imagine tackling the exploration of the deeper solar system and contextualize our own experiences on Earth within the life cycle of orbiting objects, the history of rocket-powered flight, and the longest-lived artifacts of human civilization. First, Brian Keating, Associate Director of the Clarke Center, spoke with Bruce Betts.
Hi, this is Bruce Betts,
the Director of Science and Technology and Lightsail Program Manager at the Planetary Society, about Lightsail 2.
Lightsail 2 is a solar sail spacecraft in a CubeSat format, so it's about the size of a loaf of bread before one unfurls the sails, and then it's about, the sails are 32 square meters, roughly the size of a boxing ring. And we've had interest at the Planetary Society, which is the largest space interest group in the world, in solar sailing for quite some time. We tried to fly the first solar sail mission in 2005, Cosmos 1, but it was lost in a rocket failure.
Since its founding, the Planetary Society has had an interest in solar sailing.
Planetary Society, first of all, was co-founded by Carl Sagan, as well as Bruce Murray and Lou Friedman. And Cosmos 1, part of the partnership was with Carl's widow, Ann Druyan, and Cosmos Studios, her entity at the time. So it was not at all coincidental that that was named Cosmos 1.
In fact, Carl Sagan himself spoke often about the potential for solar sailing, including with former King of Late Night, Johnny Carson.
Talk about this. This is interesting.
Well, there's a just tremendously exciting prospect called solar sailing.
Solar sailing.
And this is a very crude model, and which travels on the radiation and particles that come out of the sun, the wind from the sun. And it works exactly as an ordinary sailboat does. So it can go out from the sun, it can tack inwards to the sun, and because it has a constant acceleration, it can get you around the inner part of the solar system a lot faster and a lot more conveniently than the usual sorts of rocket propulsion.
Now, what would this do?
Well, it takes you to where you want to go. So one mission that's being talked about is to rendezvous with Halley's Comet in
I've always wanted
1986.
to do that.
The idea, though, has deeper roots, going back at least to Johannes Kepler. Writing to Galileo in 1608, Kepler speculated, and I quote, "Provide ships or sails adapted to the heavenly breezes, and there will be some who will brave even that void." The idea of a solar sail found footing in the mid-20th century in what, to some, may seem like an unusual place, in the pages of Astounding Science Fiction, one of the pulp sci-fi magazines of the day. There, an electrical engineer named Carl Wiley described how a parachute-like sail could be propelled by photons from the sun. It was a far-out enough idea, he chose not to publish it under his own name. The Planetary Society's first foray, the full-size satellite Cosmos 1, plunged into the ocean on a failed launch aboard a Russian rocket in 2005.
And then we came up with a new plan and utilized these CubeSats, which are very commonly used by universities and agencies now, and provide a way for a cheaper access to space. But one thing they lack typically is a deep space propulsion technique. So using a solar sail where you're getting pushed by the light from the sun gives an opportunity for deep space propulsion without having to carry fuel. Interestingly, we are, because the efficiency, the acceleration you get with a solar sail is proportional to area over mass, even though it had a much bigger area, it had a bigger mass, but proportionally, our spacecraft, now Lightsail tube, even though it's much smaller, is about 10 times more acceleration. And That's also true compared to the Japanese Icaros, which is so far the only solar sail mission that has flown in space, which was also much larger and less efficient, but still quite impressive.
And what do you envision, let's say things are deployed, are there materials that still need to be invented? Are there limitations due to, things outside of the delivery vehicle or the CubeSat? Are there other limitations or other challenges that you guys are facing?
Our challenge has been things like trying to shove enough material and fold it up and have it reliably put in the spacecraft and able to sit for months or years and then be deployed outside the spacecraft. The attitude, determination, and control system is a big challenge so that you can actually turn this massive, this thing that's like a extreme case of an ice skater with their arms out and you're trying to rotate it. And how you do that and how you control that and determine what your attitude and orientation is has been challenging. And then just the usual challenges, of which there are many, of trying to build a reliable spacecraft.
Now, this CubeSat will it be launched on a NASA vehicle or on a SpaceX vehicle or commercial vehicle?
The SpaceX vehicle as a secondary payload on Air Force supported launch, basically.
I see, okay.
So it's on the second or third flight of the Falcon Heavy, which has yet to debut, and theoretically is debuting in the next few months, and so our launch timing is a little uncertain. It's right now no earlier than the end of April, certainly could be much after that, and we are launched inside a Air Force-sponsored student spacecraft built out of Georgia Tech called Prox-1. It's designed to do proximity operations. We launch from that spacecraft, which is deployed from the rocket as a whole.
Okay, so there's multiple CubeSats that will be launched simultaneously?
Yes, they've got, since it's the Falcon Heavy and you've got more payload ability than you've had since the Saturn V, there are a number of spacecraft, including some large spacecraft, on the rocket. There are also a dozen or more CubeSats, and we're a CubeSat within a small satellite, Prox-1, which it gets deployed and then it deploys us.
Though in some ways a straightforward test of a set of science and engineering problems, the history of the idea of solar sailing and the almost romantic quality of that notion, clipper ships among the stars, gives Lightsail 2 an inspirational and aesthetic quality.
It's a very practical, engineering-driven, science-driven design, but I think in some ways it's a very artistic design is what comes out of it. And certainly, as you've mentioned, science fiction authors' movies have enjoyed solar sails, including Arthur C. Clarke with his Sunjammer story in the 60s.
That's Clarke's 1964 story, The Sunjammer, first published in Boy's Life magazine. We'll put a link to the story in our show notes so you can check it out. Brian and Bruce got talking about that interplay and how science fiction can inspire scientists and how advances in science fuels the ideas we find in science fiction.
Yeah, I think there's still going to be that interplay. Obviously, the more advances we make in science and the more speculative science there is, the more science fiction and artists are going to feed off of that. And if nothing else, the science fiction and the various kinds of art inspire particularly the young generations as they're coming up and get ideas in their head and visions of the future. And so I think that ties into the science and engineering that happens. And in terms of kind of the miniaturization that's occurred on Earth has been a real boon for space exploration because we're able to fly much more powerful science instruments than we ever could because of miniaturization, much more power. Obviously, the computing power we can fly now is much larger and higher and inexpensive, and CubeSats are just an extension of that, where they've standardized the sizes and the various standards of the spacecraft, which has led to more and more, and I think the Lightsail's another part of that, to a so-called democratization of space. Space is always going to be hard, I think, but at least it's becoming more reachable for universities, for, as you mentioned, even artistic endeavors.
Which brings us to part 2, and one of those artistic endeavors, the artist Trevor Paglen's Orbital Reflector project. His work spans media and has explored things like global telecommunications, surveillance, and computer vision. But this piece will be a sculpture launched into space via a CubeSat, the first satellite to exist purely as an artistic gesture, which he spoke with Clarke Center Director Sheldon Brown about via Skype.
So how did you come to thinking about this Orbital Reflector project that you're doing?
Yeah, so I mean, there's a very long history behind it. And it grew out of several kinds of concerns. On one hand, it grew out of a project that I've done for many years where I just try to track all of the secret satellites in the sky. So there's a group of amateur astronomers around the world who basically as a hobby go out and try to find and record the movements of spacecraft that they see in the sky that aren't, obviously registered with the United Nations, don't kind of show up in public catalogs. And the reason they don't show up in public catalogs is because they're, secret satellites that they're primarily American. And so I've been going out for many years and trying to track these, photograph them. These are things like signals intelligence satellites, optical imaging satellites, radar imaging satellites, kind of classified communications relays and that sort of thing. And so that was one piece of it. And in order to track satellites and photograph them, you have to learn something about orbital mechanics. You learn something about, the physical conditions of visibility in space, that sort of thing. The other piece of that the other thing that came out of that, I think, is like when you start looking at spaceflight and the history of spaceflight, it's a history that is so bound up with a kind of American mythology, about, going, it's the frontier and we're going to go to the moon and plant a flag and then we're going to go to, an asteroid and do some mining. I mean, there's this kind of recapitulation of the kind of American Western expansionist project in terms of the stories that we tell ourselves about space. But when you look at the practical history of spaceflight, Sputnik went up on an ICBM, and it was probably more of a demonstration of the ability to deliver a nuclear missile to the other side of the world than it was a demonstration of the ability to put something in orbit. And so when you look at the actual history of spaceflight, it's intimately interwoven with the history of nuclear war, so much so that I really think they're one and the same for the most part. And so the Orbital Reflector project kind of came out of a kind of question, which was, what would the opposite of that be? Is it possible to imagine a version of spaceflight that was decoupled from a military history, from a commercial history, or from a scientific history, for that matter? In other words, what would something like aerospace engineering for aerospace engineering's sake look like? And ultimately, I think that's an impossible question to answer. I don't think the practical conditions exist in which you can truly enact that. But the goal of the project was to try to get a glimpse of what that might look like, as it were. And I think the third piece of it that is really influential to me is really thinking about early Russian avant-garde art. If we look at artists like Malevich in particular, who I think is the first person who proposed an art satellite. He has an essay where he's talking about making artworks that would be in orbit around the planet. And if you look at his drawings, you see that there's many examples of that. And Malevich was very influenced by a kind of strand of late 19th century, early 20th century Russian kind of philosophy that in retrospect we call Cosmicism. It's been kind of posthumously called that. And it's kind of finds its locus in a figure named Nikolai Fyodorov, who described in the late 19th century something that he called the philosophy of the common task. And what he believed was that humans should organize all of their productive capacities in the service of a higher purpose. And that higher purpose should be to, first of all, make ourselves immortal. Second of all, to resurrect every human who's ever lived. And as a part of this project of this common task, we're going to have to develop space flight for two reasons. First of all, we're going to have to go to space so that we can collect the particles of our ancestors that have evaporated from the Earth, and we can bring them back and reconstitute them and bring them back to life. And then once we've reconstituted everybody who's ever lived, we'll have to have places for them to live. So they'll have to live on other planets. And this was very inspirational, not only to Russian avant-garde artists like Malevich, but very directly influential on early Russian aerospace. Someone like Konstantin Tsiolkovsky was the protege of Fyodorov. So all of these things kind of come together for me anyway in the Orbital Reflector project.
There's certainly still, despite your first point about space flight and its connections to nuclear war, it seems there's still this aura of utopianism that is the flip side of that coin when we think about space, and with this project, I think, and I guess another art historical reference that it brought up for me was thinking of this is like what Donald Judd might do for a space project. That there's something about his specific objects kind of idea about sculpture, which is to try to find the pure phenomenology of a form and of material, but in your case you use it, but it also I think becomes this beacon to try to to have us become more aware of the phenomena of how we use space and many more complex registers.
Yeah, for me, that's really what the project is, and I'm very suspicious about space, to be honest with you. I mean, on the one hand, there it does have this kind of utopian history associated with it, and at the same time, I worry about that utopian history in particular. I worry it bothers me that we imagine that we can live in space and that we can imagine that we can live on other planets, because I am not convinced that we can live anywhere other than on this planet at this moment. And I worry sometimes that the imagination that we can detach ourselves from the Earth causes us to implicitly think that the Earth is disposable.
So as the Arthur C. Clarke Center for Human Imagination here, the other thing that I think about with this project is, Clarke's conceptualization of geospatial satellite communication network and how that put into play a kind of use of space, a kind of sphere that could encircle the Earth, that could allow the Earth to communicate with itself, synchronously, simultaneously, which, is a kind of utopian ideal of global communication that probably helped us avoid a nuclear war or two along the way, as well as complicating, the global condition right now. And I think from all of this kind of extension of our thinking about who we are as humanity, the ability to kind of come up with a global conception of the human condition is a virtue of thinking about the orbit. But there's also maybe something about our time frame too that I think permeates maybe this project a bit, and also some of your other projects as well, that our timestamp on of what we do as a civilization is also a conception to think about stretching and understanding better.
Absolutely, and it's funny that you bring up geostationary satellites. Over the course of learning the basics of orbital mechanics of satellites, one of the things you realize about geostationary satellites in particular is that they're really far away from Earth. They're about 36,000 kilometers away, and they're so far away from Earth that they're not subject to the same geophysical forces that make other satellites in lower orbits decay and kind of come back to Earth and burn up. And so when you do the math, doing predictions about the orbital longevity of a geostationary satellite, you basically get infinity. And so what the geostationary satellites, when I did that, I called up a friend of mine who's an orbital analyst, and I said, this looks really weird. It looks like, from what I can tell, geostationary satellites don't decay. And he said, yeah, that's true. And I said, okay, well, if geostationary satellites don't decay, there's no volcanism in space. There's no erosion. There's no, wind and rain and that sort of thing. So what that means is that these are potentially the longest lasting human objects that we've made, right? That basically geostationary satellites, when they power down and die, they stay there. And in a way, the humans have created a ring of machines around the planet that's now a permanent part of the planet, which is sort of embodied in those dead geostationary satellites. And actually, in 2012, I did a project with Creative Time and MIT, where we made a series of pictures that were then attached to one of these geostationary satellites, and then went into orbit, where it will just kind of float around for millions or potentially billions of years, and where they were all images that kind of had to do with the ways in which humans shaped the planet, shaped the surface of the Earth. And but you're absolutely right that there is these sorts of timestamps that start happening when you start thinking about space and you start thinking of the cosmos that are totally alien to how we experience time and how we experience, even the lifespan of a generation or a society or what have you. And I think that those are really helpful. I think it's really helpful for us to be able to kind of create situations that force us to think on either longer time spans or shorter time spans than what we encounter in our everyday lives, because of course the impact that we have on the planet plays out over lengths of time that are also alien to our everyday experience. If you think about something like climate change, which plays out over decades or thousands of years, or something like radioactive waste that plays out over hundreds of thousands of years, I think this is a place that I think space is useful to think about, is to defamiliarize, at least conceptually, how you understand what a horizon of time is, or a temporal horizon.
Well, so speaking of temporal horizons, what is the temporal horizon for the Orbital Reflector project? Hopefully not millennia.
No. So it's the exact opposite of the last picture. So the last picture stays there forever, that was the geostationary project. This one lasts just a couple months. In fact, it's sort of designed to be highly influenced by geophysical activities and solar activities as well. So what happens is that it has the spacecraft it's a CubeSat. It's a 3U CubeSat, and when it goes into orbit, it inflates a giant kind of diamond-shaped structure that's about 100 feet long and about 6 feet tall. And the whole project is just designed to reflect sunlight down to Earth. So it's designed to be visible in the sky as a kind of slowly moving object, about as bright as one of the stars in the Big Dipper. And because it has such a high volume and such low mass, it's very influenced by really atmospheric drag and solar radiation pressure. So what happens is that, there's no fixed line that separates the Earth's atmosphere from space. I mean, you can just think about the atmosphere getting thinner and thinner and thinner and thinner. But even if you go up, 500 kilometers, even 1,000 kilometers, there's still, little, molecules of, CO2 or what have you that are in space. And what happens with most spacecraft in lower Earth orbits is as they move through an orbit, they are, being hit by, atmospheric molecules, and that creates very small amounts of drag, and that drag adds up over time, and that can be over a couple of years, or that can be 100 years or 1,000 years or whatever. But that's what kind of brings the spacecraft back to Earth. And with this particular shape, it's highly affected by drag because it has such a large volume and very low mass, so it has a very low ballistic coefficient. And so what happens is that it comes down after a couple of months. You can't entirely predict it because it's dependent on the weather on the sun, because if solar weather affects the Earth's upper atmosphere and can kick more or less of these upper atmospheric molecules into space. But it has a very short lifetime.
When do you expect it will come to life?
We're launching we have a rocket reserved for next year, so it'll launch in, it was supposed to be April 2018. That launch window has now been pushed back to June, July. So I expect it to launch summer of 2018. And we're going into our final testing phases right now. We're doing our thermal
who does the launch?
It goes up on a SpaceX rocket. It's going up as what's called a secondary payload. So basically, we buy leftover space on a rocket that's for a much bigger satellite. And there's an intermediary company that basically will sell you that extra space, and that company is called Spaceflight.
Especially in light of this being an artistic project and one deliberately, in his words, decoupled from that military-industrial history of spaceflight, We asked if that changed the process of developing and building the orbital reflector itself.
Yeah, it's a really good question. You know, this stuff is hard to do, and it's hard to develop the confidence of the people that you need to work with to be able to realize a project like this. And the kind of longer arc of it was that when we were developing the Last Pictures project, the geostationary project, we were on sort of some very extreme deadlines and needed some very technical work done very quickly. And basically the way I got the project done was I would literally have a problem I needed to solve, like some test that needed to be done or something that had to be engineered. And I knew that these were ridiculous deadlines, and I basically didn't have a budget. And so I would just call literally every single person that could do this in the country, explain the project to them. And every single time within a couple of phone calls, I found somebody who just thought, like, this is amazing. I want this to happen. I'm going to drop what I'm doing, and we're going to do this project. And what I realized, I think over the course of that project, there's so many people in the aerospace engineering industry who got into it because they were thinking about the sky and thinking about these kind of big questions. Who are we? Where we come from? What is our relationship to the cosmos? And then you get in a job like that and you realize it's pretty quotidian, at best, at worst, you realize you're building, military vehicles and that sort of thing. That's not really what a lot of people signed up for. And so I think that project sparked a kind of goodwill from a lot of people in that industry. And the other thing is that space is really hard to do. And I think that was the other thing that the industry took notice of, was like, wow, it is possible to do these somewhat ridiculous, or fanciful, or definitely highly impractical projects in space. And so that I found a lot of goodwill from people in the aerospace industry as a result of doing the Last Pictures project. And that opened up a lot of doors in terms of people that would be willing to help with this project. That on one hand. And then on the other hand, I spent many years getting the project to the point where I could credibly go to an institution and do the actual fundraising and, have a real project and have people in place that had the experience to be able to realize this. So one of the other things that happened was on the Last Pictures project, the program manager of that project retired, and I proposed a guy named Zia Abudiat. He's a fantastic guy. And he retired, and we were just having drinks one night, and I said, well, why don't you work on Orbital Reflector as a retirement project? And he agreed to do that. And so, just that, having those kinds of people in place is really necessary in order to realize a project like this, and developing those kind of relationships and the kind of confidence that you need to be able to, that other people need to have in you. It just takes a long time.
And that's something I find especially meaningful. How looking up and speculating on the possibilities there changes the terms through which we relate to one another, and how we imagine our future as individuals, communities, and as a planet.
Satellite of love. Satellite of love. Satellite of love. Satellite of.
This has been Into the Impossible, a podcast of the Arthur C. Clarke Center for Human Imagination. We'd like to thank Trevor Paglen and Bruce Betts for speaking with us, and acknowledge our generous sponsors and patrons, including Viasat Inc., members of the Founders Orbit, and the James B. Axe Family Foundation. Their support is much appreciated. To find out more about the Clarke Center and other exciting projects, research, and programs, as well as how to support our mission, please visit imagination.ucsd.edu or find us on Twitter or Facebook. On December 7th, we're hosting an evening with science fiction writer Andy Weir, talking about his new novel, Artemis, set on a lunar colony. Come and join us if you can. Audio production is by me, Patrick Coleman, produced by Patrick Coleman and Sheldon Brown. And thanks to everyone who's been listening to the podcast and sharing it. Please continue to do so. We really appreciate it. And don't be shy about leaving a review or a comment, sending us an email. We'd love to hear from you. Thanks.
The only thing we can be sure of about the future is that it will be absolutely fantastic.
5, 4,